All right, we get this rectangular tank, and the important part as far as graphing goes, it says initially there's 4 cubic feet of water in the tank. So if I'm going to graph V, that means that V of 0 is 4. So I would go ahead and put this ordered pair, 0, 4 on the graph, like so. Well, then how do you figure out how to graph this part here? Well, since V prime is graphed here, V is the antiderivative of V prime. So for example, this right here has a slope of 2. The equation of that line would be y equals 2t. The y-intercept is 0 and the slope is 2. That's what this says here. V prime is 2t. This is from 0 to 1. If you integrate that, then you're going to get what V is. When you integrate this, we don't know what the constant is. That's why when we integrate V prime, we're going to get t squared plus c. We don't know what c is. But as long as we know one ordered pair on this curve, we can figure out what c is. And we know an ordered pair because we were given the initial value here of 0, 4. So you put 0 in for t, you put 4 in for v, and solve for c, and we figure out that this is a parabola, t squared, plus 4. So the entire graph is shifted up 4. Vertex would be at 0, 4. That's how we get this graph right here. So that concludes, this part of the answer. Moving on to the next part. This next part is linear. It's a line, y equals mx plus b. You can use point slope form too when it's helpful. This is a horizontal line from 1 to 4, and it's at 2. So that's why I'm saying v prime is equal to 2 from 1 to 4. If you integrate that once again, you're going to get 2t plus an arbitrary constant. Only it's not arbitrary because we can figure out what this constant is. To figure out what that constant is, we need one ordered pair. And to figure out where the ordered pair is, you figure out where the last graph ended. This is going to be a continuous function. It ended at 1, 5. So we put 1, 5 into this, 5 in for v and 1 in for t. Figure out that c is 3. So our linear equation is 2t plus 3. And that's what I have graphed here. So we continue with where we left off. Slope is 2, slope is 2, slope is 2. We end up at 4, 11. That ordered pair we're going to use to find the next arbitrary constant. That is the second part of this little fellow. The next part of the graph, we need to know what the slope and y-intercept is. The slope of that is -1, which I have right here as negative t. And I found the y-intercept easily just by looking at this graph, and we could see it would hit at 6. There's other more complicated algebraic ways to find it, but that's going to be pretty simple to do that. That represents v prime. V is the antiderivative of that. If you integrate this, you're going to get this little fella. Once again, this arbitrary constant that's not arbitrary. We need one ordered pair we know is on that curve, and that's here, because this is a continuous graph, so we know 4, 11's on the curve. Put 11 in for v. You put the 4 in for t. Do yourself a little algebra, assuming that I added and subtracted right, and end up with c is -5. So the third part of the graph of v is -1/2 t squared plus 6 minus 5. Now to graph that, it's easiest if you know where the vertex is. This is the vertex formula for h, negative b over 2a. My b in this case is 6, so I have a -6. My a in this case is -1/2, so 2 times -1/2 is -1. If you divide those, you get 6. So I know my vertex is at 6, which is, I don't know how high up it is, so I want to put that 6 back into this function. So that's what k is going to be, and I didn't show the work for this for some reason. So k is going to be -1/2 times 6 squared plus 6 times 6 minus 5. Hopefully this ends up being 13. So this is a 36 times a -1/2 is -18 plus 36 That gives us 18 minus 5. So yeah, that gives us the ordered pair. 613, that's the vertex. So if I put that on here as the vertex of this parabola, all I need to know now is what the coefficient of t squared is. It's negative 1/2. That means the parabola opens down. I'm graphing this part right here. It opens down, and normally for a parabola, you go to the right one, you square it, and then you go up one, because 1 squared is 1. Here, we're going to go left, because the only part of the graph we're doing is between 4 and 6. So left 1, 1 squared is 1, but the negative 1/2 says you go in the opposite direction, and you go half as much. So that's why I went here, negative 1/2. That's what this point right here is. Then normally for a parabola, you put a 2 in, 2 squared is 4. So you go right 2 up 4, left 2 up 4. But in this case, since it's a negative 1/2, we go left 2, 2 squared is 4. You're supposed to cut that in half and make it negative, so it's down 2, which puts me where I'm supposed to be, supposed to connect to the other graph. Hopefully that makes sense. That was a lot of pre-calculus stuff that you may or may not remember. Then, so that represents the third part of this. The fourth part, pretty simple. V prime is linear and it's at 0. So if V prime is 0, integrate that, you're going to get V is some arbitrary constant. And to figure out what that arbitrary constant is, we need a point that's going to be on this. And if you look up here, this previous graph ended at 613. So the y value is 13, so that constant has to be 13. So for this fourth part, we get 13. And once again, that's just a horizontal segment, what we see right there. That ends up at 813. We're going to use that 813 for the last ordered pair and figure out what that not so arbitrary constant is. So the last part of this graph, it goes up 3 into the right 2. That's the slope. What's the y-intercept going to be? Well, that's tough looking at the graph to know what that is. So I use point slope form where I filled in the slope is 3 over 2 and an ordered pair was 8, 0. That was a point on my line. If I solve this equation for y, I get that this v prime is 3 halves, should be a t, not an x, minus 12. So this line right here is 3 halves t minus 12. That will be the y-intercept. So that means that v prime is that. Whoops. If I integrate that, I get this fella with the arbitrary constant of c. Take the ordered pair that I left off with, 813, I know that's on the graph, and I plug that in, and end up with c is 61. Hopefully I did my math correctly there. Once I know that's 61, I want to find the vertex so I can figure out how to graph this little fella. And I luck out that when I use this vertex formula, put negative b, negative 12 in for that. Negative 12 is a positive 12. And then on the bottom, it's 2 times a is 3/4. So 2 cancels with this, we get 3 over 2. It ends up being 12 times 2 divided by 3, which is 8. So why does that make me lucky? Well, if the vertex is 8, then I know I'm starting my parabola right here. Normally, you go to the right one and up one because 1 squared is 1. But if this coefficient is 3/4, that changes my scale. It's a vertical shrink of 3/4. So instead of going up 1, I go up 3/4. That's what puts me here. Then normally I go to the right 2 and up 4 because 2 squared is 4. This says only go 3/4 of the way. 3/4 of 4 is 3. So I'm only going to go up 3, which puts me here, which is the ordered pair 10, 16. And that concludes my graph. This was the last part. I have my curve up there. Hopefully that made some kind of sense to you. If it doesn't, let me know, and it's much faster if you send me a text because I rarely check my email. Peace out.